So, welcome to this new lecture of the online lecture series of hydraulic machines and water power engineering. So, we are having a new topic, that is Pelton turbine, or generally it is known as Pelton wheel turbine. See, first of all, why it is called Pelton? So, it is named as Pelton on the name of that American engineer, that is L.A. Pelton, who discovered or invented that type of turbine. So see, we have discussed in previous lecture, we have discussed various types of turbine or various classifications of turbines, such as mixed flow turbine, radial flow turbine, impulse turbine, and various turbines. So it is a type of tangential flow impulse turbine. What it means? It means that in Pelton turbine, the flow takes place in the tangential direction to the vanes. So this diagram is showing you the runner and its bucket. So see, if you can see the in right corner, in right side of that slide, that these are some runners with bucket. So when water is striking in the bucket, so the water is striking at the tangent. If we assume there is any circle, so the water is striking at the tangent of that circuit. So that's why it is known as tangential flow turbine. Now, why it is called impulse flow turbine? Because in this type of turbine, the water is striking the bucket suddenly. That means impulse load is applied on that bucket, so it is known as impulse flow turbine. Next, the energy available at the inlet of the turbine. See, where the penstroke is ending, there is a nozzle provided. So this portion is called inlet of the turbine. So see, the energy that is in the form of kinetic energy, hence it is also based on kinetic energy conservation. So see, it is a turbine which works under high head, hence it can be used for lower discharge. uh, I will also explain you what is the meaning of the lower discharge term. See, the pressure at the inlet is atmospheric and the pressure at the outlet is also atmospheric. This diagram shows you the typical shape of any so you can say Pelton wheel or Pelton turbine. So these are some components of the Pelton wheel or Pelton turbine. So these are the components. Number one is called nozzle with the penstoke. We will discuss it later. Next is called runner with shaft. Next is vanes of bucket. Next is the casing for this safety purpose. So a Pelton wheel or a Pelton turbine is the combination, or it is the uh, you can say assembly of these parts. So this will work when these parts are attached or mounted properly. Now, first part is nozzle and flow regulating arrangement. See, what is nozzle and the flow regulating arrangement? See, when we are taking water from the dam and the water is conveyed through a large diameter pipe to the turbine. So this large diameter pipe is known as penstoke. This penstoke may be of steel or RCC. So this penstoke is connected to the turbine and it ends like a conical shape. So this conical shape, or this shape of small area of the last point of this penstoke is known as nozzle. So this water strikes the vein. The water when it strikes the vein is coming out from a nozzle. So see, in nozzle, there are two so-called, you can say, equipment are installed, or the arrangements are installed. These are known as regulating arrangement. First one is the spear and next one is the deflector. In the next lecture, when we will discuss about the working procedure of that Pelton turbine. So we will be discussing about the function of that sphere as well as the deflector. Next portion. The next portion is runner with vanes and buckets. So see, this diagram shows you the typical shape of the runner of a Pelton wheel, and these the portion which are projected outside are known as so-called, you can say, bucket. So this runner is attached to a shaft. The portion which is projected outside is a cylindrical portion, is known as a shaft. As we know, the shaft is used to transmit the energy from one component to the another component. So these shafts are moving, or it is rotating with an revolution per minute speed, that is called rpm. And these buckets are attached when water strike these bucket, so that this bucket are moving. So due to this movement of this bucket, the shaft is also running. The shape of the bucket is kept double hemispherical, so that the splitting of water can be takes place easily, so that each bucket is divided into two symmetrical parts by dividing wall, which is known as splitter. So see, that is the third part of this Pelton wheel turbine. The third part of this Pelton wheel turbine is known as casing. The function of the casing is to prevent the splashing of the water and to discharge water to the tail race. It also acts as a safeguard against the accident. That means it is a boundary that is provided in the Pelton wheel turbine. Generally, it is made of steel or cast iron, and the casing is generally for safety purpose. It does not perform any hydraulic, so-called, you can say, it does not prevent any hydraulic task. So, if we consider the Pelton turbine, so that we can say the most important part of the wheel is, of course, the bucket. So that the bucket is responsible for the movement of the turbine or the movement of the shaft. So the bucket has a central splitter ridge on the top, which at which the jet of water from the nozzle strikes, and the water splits into symmetrical flow in each lobe of the bucket. The nozzle that is directly attached to the penstock, it also governs the quality of flow with the help of a spear valve controlled by the governing action. So see, the simplest form of the arrangement is when there is a single nozzle feeding water to the turbine. However, a limitation of discharge that can be utilized for the wheel. So that these are the basic components of your Pelton wheel turbine. Uh, the Pelton turbine, let me summarize about the Pelton turbine in 2 minutes. So the Pelton turbine is a high head, low discharge turbine. Second point is, this Pelton turbine is based on momentum conservation theory. Next, it has double semi-elliptical shaped bucket, which is splitted by a section called splitter. A casing of steel is also provided here, and the braking jet that is also. Hello, welcome to this online lecture series of hydraulic machines. I am SHUBHAM from Civil Engineering Department, SISTec-R, Bhopal. So, we have discussed about the components of Pelton turbine in the previous lecture. So, in this lecture, we will be discussing about the working of that Pelton turbine. That means how the Pelton turbine works and what are the various features of different accessories that are attached with this Pelton turbine. So first of all, let me start with some points. So the flow takes place in Pelton turbine due to kinetic energy, and the power that is also produced due to the kinetic energy only. That means the energy of water which we have stored in the dam before the dam, so that the water energy is in the form of that potential energy, and when we are conveying this water through a penstoke, and the penstoke water is striking with the help of a nozzle to the turbine blades, so this potential energy is converted into that kinetic energy. So hence the power is generated also due to the kinetic energy only. So the pressure at the uh, inlet and the outlet of any Pelton turbine is atmospheric only. Now it is based on momentum conservation principle. Why it is based on momentum conservation principle? So see, when the water is flowing in the penstoke, so it has some velocity, and at the we can see in the bottom of this slide the typical section of the outlet of the penstoke. So see, at the nozzle portion the area is very less. So if the area is very less, so the velocity will be increasing, and in the penstoke where the area is large, so the velocity will be very less. So due to this the conservation of velocity should be maintained. Next point is the Pelton turbine works under a lower discharge. It means it is a high head Pelton turbine. Next, the portion that is to be discussed is spear. So what is a spear? Uh, Spear, generally it is a type of valve or a type of gear that is attached to the Pelton turbine. So the function of the spear is to maintain the high and low discharge during the loading of turbine. So what is the meaning of this loading of turbine? See, the meaning of this loading of the turbine is that in turbine, generally when the water is conveyed from that penstoke and the water is strikes to the vane, water is striking to the vane. So this process is known as to apply load on the turbine or any Pelton wheel. So this process is called loading of turbine. And when there is no flow of water in the penstoke, that means the water is stored at the stem side only. So this process is called unloading of turbine. So we can also say the loading process is responsible for power generation, and the power is generated only when there is load of turbine. So spear generally takes care of loading of turbine, and it maintains the discharge, because during this operation of this loading there may be chances of fluctuation in the discharge of turbine. So this spear is generally a cylinder or a attachment that is operated with the help of a wheel, just like a valve that is provided in our water tanks or other things, so that we can regulate the flow of water in that penstoke. Our next part is the deflector. So see, what is the deflector? Deflector is a special arrangement that is provided with that spear. See, when the water is conveyed from that penstoke, so we know that in pipe flow there are chances of water hammer pressure. So due to this water hammer pressure, there are chances that pipe may be burst or something like that. So this deflector is a opening, generally it is a opening that is provided for the purpose of avoiding the water hammer. Hence we can say, due to the high discharge by spear, water hammer pressure will be generating in the turbine or in the penstoke. So to avoid this water hammer pressure, for the safety of this nozzle and that penstoke, we are providing it a deflector. Next portion is casing. So what is a casing? A casing is generally made of cast iron or steel. It has no use, but it is used for the safety purpose in our turbine portion. Next is a part that is called braking jet. So braking jet is provided to maintain the speed of runner during the loading and unloading of turbine. See what happens during the loading of turbine. During the loading of turbine, there is very much amount of or very large amount of water available here, so that these veins are attacked veins are being attacked by the water, and when the water strikes on the vein, the veins are moving very fast. So this fast movement should be maintained by the braking jet action. And opposite to this, when we are unloading the turbine, so that there is no water, so during this no water, the veins are suddenly stopped. So to maintain this stopping and operation process of this veins and buckets, is there is a apparatus that is applied in the turbine, so called, you can say, is known as braking jet. So this is the function of this braking jet. So see, it is a very important concept here. That is the buckets or the vanes that are provided to the Pelton turbine are kept in the shape of double hemispherical, and these are also symmetrically splitted by a point, by a portion that is called splitter. These two diagrams show the shape and the section of any so-called, you can say, bucket section. So this bucket is connected to the runner, and when the water, we can see in the downside figure, in the figure which is plotted downside of that logo of this stack. So this water, when strikes in the bucket, to the bucket, so this water is so called, you can say, conveyed, or it turns with the this periphery of this you can say bucket. So this periphery of bucket is guiding the water, and the force that is generated is also in the vertical as well as horizontal direction. This angle provided backside is known as angle of deflection. Generally, the angle of deflection is kept 50 degree to 70 degree. Generally, it is kept 65 degree for convenience purpose. So see here the power generated. If we are going to derive the expression for that power generation in Pelton turbine, so this power or load generation in the turbine, what is the meaning of the power? So from the definition of power, it is clear that power is defined as the rate of work done. So what is the rate of work done? That is work divided by time, or work can be also written as force into that displacement into that divided by time, and the portion of displacement divided by time will take about the velocity. So hence the expression of power can be given by force into wind's velocity. So what is the velocity? It is also known as speed. So this speed of wind u, that is on what rate the winds are moving. So this speed of velocity winds u is given by an expression that is pi d n divided by 60. Hence the formula for power will be P equal to F bracket pi into d into n divided by 60, where F is the force of strike due to water, pi is the constant, d is the diameter of this runner circle. If hello and welcome to this lecture series of fluid mechanics and hydropower engineering. So in the previous lecture, we have discussed about the Pelton turbine and its working. So this new lecture is consisting of the reaction turbine, or the example of a reaction turbine is a Francis type of turbine. So in Francis type of turbine, it is a radial type turbine. So the meaning of a radial turbine is that in this, see, you can see also in this diagram that is shown at the top corner. See, the arrows are showing the water direction. So when the water comes from that pen stove, so this due to this movement of water, the radial flow takes place here. So such type of turbine are called radial flow turbine. The next point, it is inward flow reaction turbine. Why it is inward flow reaction turbine? Because it is clear from that diagram at top corner that that arrangement is done in such a way that the water is surrounded by a spiral steel casing, or it is just like a pipe of large diameter. So this the flow takes place inside this spiral casing, so hence it is known as inward flow reaction turbine. Name of the engineer that who discovered this Francis turbine was J.B. Francis. So the turbine was known as Francis turbine. The main part of this turbine we can see in the figure. One is the spiral casing. In the case of Pelton turbine, I have told you the casing was not spiral. It was just like boundaries. That boundaries are provided for the Pelton turbine, but here the spiral casing is provided. Next is the radial runner. So the runner of that Pelton in the previous lecture was just like a shaft runner, but here the runner is also radial, and here two type of runner are used. One is the radial runner, and second, two type of wheel are used, or vanes are used for the runner. One is the radial runner, other is the stay or guide wheel runner. Next is penstoke. We know that a penstoke is a large diameter pipe that is used for the conveyance of the water in the turbine. So now further we are discussing some important point of that Francis turbine. So the components of that Francis turbine. So first component is casing. So as mentioned above, the casing of the runner that is generally full of water. So it is the water when penstoke when enters from the penstoke, the spiral shape casing is provided, so that the complete casing completely surrounds the runner, and the casing is made of concrete or cast iron or steel. Next is the guiding mechanism. For guiding mechanism, the guided vanes are fixed on the turbine. So the guide vanes allow the water to strike the vanes, and this will take the formation of that radial inward radial flow. So due to this inward radial flow, the power is generated, and the power that is a part of energy, that is the rate of energy done, energy work. So this power or the energy from the turbine is supplied to the generator with the help of any shaft. Next is third portion, that is runner. So it is a circular wheel that is mounted over the shaft, so that when the blades are moving or vanes are moving, so that runner is also moving, or due to this runner movement the shaft is moving. So shaft is transmitting this water energy to this generator, or so called, you can say, the electricity production system. The runner generally made of steel or iron, so they are guided over the shaft. So this diagram will show you the working principle of this Francis turbine. So in Francis turbine, generally following arrangement. So the top diagram, this is the diagram has two parts. So the upper part of diagram will show you the elevation of that so-called, you can say, sectional elevation of the turbine. In this, D1 is the outer diameter and D2 is the inner diameter. The black portion is the guide vanes and the red portion are the moving vanes. So the plan is shown in the lower part. In that the hedged portion is we know that this hedged portion is the shaft which is used for energy transmission, and the outer circle which is the last boundary of that plan is your runner is your casing, and this portion attached to this hedged portion or shaft portion is our runner, and two types of blades or two types of vanes are provided to the runner. One is moving vane and other that is moving vane, other is guide vane. So this two type of vanes are having different functions. So hence we can understand the component of that Pelton turbine. So next we will take forward the working of Francis turbine. So first of all we have to study some we have to read out some important point which are very so called you can say important for from the point of view of your exam. So first point is the power produced in the reaction turbine is due to the kinetic energy as well as the pressure energy, because here the pressure is not atmospheric. That means the pressure at the inlet is more and the pressure at the outlet is less. In the next slide I will show you how the pressure is changing. So this is from the diagram it is clear that it is a airtight system, so that there are no chances of atmospheric pressure. And since the movement of the water is in radial direction, so hence angular momentum is generated here. Hence it is not based on only momentum conservation principle, but it is based on the conservation of angular momentum that is given by the expression torque into that angular velocity omega. A stay vane is also provided at the outer portion. So what are the function of that stay vanes? And so the function of stay vanes is to avoid the formation of eddies. What are the eddies? When any water, when anything or so called you can say any block is attached with water, and when water is striking it very fastly, so due to turbulency the some waves are formed. These waves are called eddies. So this stay vanes are in the shape of the airfoil body, and this airfoil body is very suitable for flow. That means here separation of flow will not take place. In the previous unit of that flow on submerged body, we have discussed in the class about the streamline body. So this streamline body are the bodies whose shape are according to the water flow. So this bottom diagram shows the airfoil body. That means in airfoil body the water does not form any eddies. That means it smoothly passes the body. So such type of advantage can be taken in the Francis turbine with the help of these stay vanes. Now I will show you what are the reasons that the pressure is not constant in this turbine. So see, if we see this the diagram of this Francis turbine, so in this Francis turbine it is to be observed that the area of that portion, that means the area of that casing or area of that so called you can say tube, is not constant throughout. It means when water comes from the penstoke into spiral casing, so the area. Hello and welcome to this online lecture series. Uh, I will be discussing in this lecture about some numerical problems that are very important from exam point of view as well as from gate exam point of view. These are very important numerical. So one of this type of numerical we have studied in the previous one lecture about the parachutes, and the next type is about the kite numerical. So what will be the approach? Our approach will be that we will be allowing ourselves to uh, reading this numerical 2 to 3 times, and then we will write the data given and then solve. So I'm reading this numerical. A kite of 0.8 meter into 0.8 meter size, weighing 0.4 kilogram force, that is also 3.924 Newton, assumes an angle of 12 degree to the horizontal. The string is attached to the kite and makes an angle of 45 degree to the horizontal. So the pull on the string is 2.5 kilogram force. When the wind is flowing at a speed of 30 kmph per hour, kmph, that is kilometer per hour, find the corresponding coefficient of drag and lift. The density of the air is given as 1.25 kilogram per meter cube. So in the solution, first of all we write the data given. So that is data given here. So what is given? First is projected area or the size of the kite, that is zero point 0.8 meter size, 0.8 meter. So that is 0.64 meter square is the projected area. Now weight of the kite is given to you, that is zero point 0.4 kilogram force. There is no need to convert this kilogram force into Newton, because in question it is also given, but in some questions there is the data is not given, so that we will calculate this by multiplying 9.81, because the difference between the mass and weight is 9.81. The angle made by the kite with the horizontal is 12 degree, and the string that is attached, that it makes an angle of 45 degree to the horizontal. Generally in our childhood we flied, we have a very important task during the winters, that is for flying kites. So everyone has flown any kite. When we fly a kite, we have to attach any string to the kite, and when we keep this kite in the atmosphere or the in the sky, so this kite does not move vertically. The approach in this question is that when we fly any kite, so the kite does not move vertically. What we do, we keep this height constant and then we fly the kite. So the kite, the catch is in this question is that the kite moves horizontally, so the force which is applying in the horizontal direction will be equal to the drag, and the force which will be applying in the vertical direction will be the lift. This is the catch. So this is the diagram of this question. This rectangular portion I have made is this is like a kite, and these are some axes, x and y axis. So the kite is attached with a string, and that string is using a 45 degree angle. So what will be the condition of equilibrium here? The air is moving 30 kmph speed, so we can convert this into meter per second. So what will be the equilibrium condition here? For the equilibrium condition, what will be the drag force? The drag force will be force exerted by the wind in the direction of motion. So what is the direction of that motion? The motion direction we can see in the figure. The motion direction is horizontal. Why? Because it is clear to you that the kite does not move vertically. The kite is kept at a constant height, then it is flown by us. So this kite moves horizontally, so the force which is acting in horizontal direction will be equal to drag force, that is cos component of that inclined p force. The p force is inclined, so it has two component, one is horizontal or cos component and other is sine component. So cos component will be equal to the drag force and the sine component will be equal to the lift force. So here it is cos component will be equal to the drag force, hence we can determine the value of this drag force, that is drag coefficient CD. So what we will do, we will apply the condition of equilibrium, so that is CD into A into rho into V square divided by 2 is the expression for drag. that we will keep for this, and then we will apply p cos theta. By applying this p cos theta, we will be using this values of CD, and we can find the value of CD. Similarly for lift, the two forces which are acting for lift, see in the figure, the first of all the weight of kite is acting for the vertical direction, next is p sine theta. So these two take care of lift, hence we can find out the lift force. So these are the two forces which are applying here. So see, these are the, so similarly we can solve any of numerical for this kite. Again I am explaining you that first of all we have to see this diagram. So this diagram, the kite is tilted at 12 degree, so this theta 1 has no importance in our numerical, but the string that is applying a force, the force that is v, generally what we do when we fly kite, so we apply the force that is pull on the string. So this pull is equal to 2.5 kilogram force. So this 2.5 kilogram force is responsible for the movement of this kite. And again it is very important point in kite numerical, that is so called, you can say when we fly a kite, so we do not move it vertically. If you have flying a kite, so when we fly a kite, we fix the kite at a particular height, and then we start flying that kite. So during this flying of kite, and the kite moves horizontally and vertically, so this horizontal movement will take care of the drag force that is denoted here by FD, and the vertical force that is take care about the lift force. So what are the lift forces? These are the forces which are acting in upward direction. So these upward forces, I think these are consisting of two forces. One is this weight of kite, that is 0.4 kilogram force acting downward, and next is the sine component of this p force. Why sine component? Because p is an inclined force, and we know that from engineering mechanics or from physics, when we are having any inclined force, so we have to provide it two components. One is the vertical component and other is the horizontal component. So vertical component is p sine theta. Why it is sine theta? Because if you make a triangle, so sine theta will be suitable for the perpendicular. So this it is a perpendicular, and cos is suitable for the base. So p cos theta will be according to the base of this triangle xp triangle. So this whole procedure is followed in various numericals. So you can try at home your numerical. If you don't have any numerical, so I will be from the next week I'll be sending you the online assignment, that is in our class we have discussed about three assignments. So I will be issuing you fourth and fifth assignment. So you have to submit that assignment online, and then I will be preparing for, I will be showing you the RGPB previous year papers. So we will be solving some RGPB previous year paper here. So this will be the approach for the next few days, when, because the exams are to be scheduled in first week of, I think, May. So until the lockdown is going on, so we will be trying to learn the things through online platform. So you can refer YouTube, and you can also refer my online notes for the various